Good evening one and all. First of all, I welcome all the students and the participants who are attending this live lecture. Today in this live lecture, we shall see actually the syllabus part of a mechanics second. This mechanics second is also called as a dynamics. Mechanics second is also called as a dynamics of a particle in 2 dimension. So, in that dynamics, first we shall discuss the kinematics and the dynamics of the particle in 2 dimension. चला रे स्टूडेंट्स, अटेंडन्स द्यायचं प्रत्येकाने. कायनेमॅटिक्स अँड डायनामिक्स ऑफ particles in 2 dimension. Actually, this is the lecture number 2. In the previous lecture, in the last lecture, we have seen that the syllabus for the mechanics second, जो हमने पिछले लेक्चर में mechanics second के बारे में जो syllabus we have discussed. Now today we shall discuss the first unit. We shall start the syllabus, actually syllabus of the first unit. In the first unit is belonging to the kinematics and the dynamics of a particle in 2 dimensions. What is meant by kinematics? What is meant by mechanics? All these concepts you must know. Kinematics and dynamics of a particle in 2 dimension. In plane, we have to discuss only the kinematics of a particle in a plane. हमें यहाँ पे जो kinematics होता है उसको plane में discuss करना है. तो चलो introduction. First we shall discuss what is meant by the kinematics, what is meant by the dynamics. Okay, you know that mechanics. What is the mechanics? Now you can tell me the mechanics. Mechanics means what? Actually, this is the branch of a mechanics. Dynamics is the branch of a mechanics. Mechanics. What is meant by mechanics? It is the branch of a mathematics. It is the branch of a mathematics. Mathematics or science. It is the branch of a mathematics which deals with the nature of forces and their action on material bodies. See this, what is meant by mechanics? What is meant by mechanics? Mechanics means, actually it is the branch of a mathematics which deals with the study of nature of forces. Actually, in this branch we shall discuss the nature of forces. It may be equilibrium. In the first part, in the first section, in the mechanics second, first we have discussed the total number of syllabus which are based on the forces are in equilibrium. Forces are in equilibrium. Okay, no problem. Mechanics means it is the branch of a mathematics which deals with the nature of forces and their action on the material body. Second, dynamics. Dynamics is a branch of a mechanics. So we can define the dynamics. What is meant by dynamics here? आता या ठिकाणी आपल्याला डायनामिक्सचं पाहिजे. डायनामिक्स Actually, mechanics second is also called as a dynamics. Mechanics first, mechanics second. In the mechanics first, we have discussed the nature of forces, but under the consideration of इक्विलिब्रियम फोर्सेस. पहा तुम्ही जो आपण मेकॅनिक्स फर्स्टचा जेवढा काही पार्ट वापरलेला आहे त्यामध्ये सर्वच्या सर्व कंडिशन आपण इक्विलिब्रियम फोर्सेस ही कंडिशन घेऊन पाहिलेलं आहे. तर आता या ठिकाणी डायनामिक्स मीन्स व्हॉट? इट इज द ब्रँच ऑफ मॅथमॅटिक्स or it is the branch of mathematics it is the branch of mathematics, or it is called as a science or mechanics, branch of mathematics or mechanics, which deals with the motion. आता इथे या सेक्शन मध्ये आपण मोशनचा अभ्यास करणार आहोत. मोशन ऑफ, सी दिस, which deals with the motion of bodies and which is motion of the bodies, which deals with the motion of bodies due to the force. Due to the force. Actually, basically फरक लक्षात घ्या. In the mechanics first, we are also seen the effect of force in a plane, but we consider the condition under the condition of the equilibrium. But here in the dynamics, we have to discuss the effect of a motion on a body. That means we have to discuss the motion of the bodies. Motion of body means it is the effect of a force. After applying the force, what is the effect on that body? We have to discuss. That means dynamics. This is the second part of mechanics. First part मध्ये काय असतं? फक्त फोर्स या ठिकाणी अभ्यास करतो, नेचर ऑफ फोर्सचा. आणि डायनामिक्स मध्ये इफेक्ट ऑफ फोर्स. दोन बेसिकली फरक लक्षात ठेवा. इफेक्ट ऑफ फोर्स, ॲक्च्युअली देअर आर टू पार्ट्स ऑफ द, it is divided into, actually dynamics is divided into two parts. It is divided into two branches. It is divided into two branches. Dynamics is divided into the two branches. First is called kinematics and second is called kinetics. First is called kinematics and second is called kinetics. आता कायनेमॅटिक्स अँड कायनेटिक्स म्हणजे काय? तर कायनेमॅटिक्स इज concerned purely with the geometrical aspect of the motion. See this here, kinematics first. Kinematics means this concept is concerned with purely with the geometrical aspect of the motion. It is a purely geometrical aspect of the motions here. Okay. It is concerned with which is concerned with purely with the geometrical aspect of motion, of the motion. geometrical aspect of the motion. What is the geometrical effect of the motion? We have to use only the geometrical consideration of the effect. And second, what is meant by kinetics? Kinetics means, what is the kinetics here? Kinetics means which deals with the effect of force on a motion. Okay, it is the effect of force on the motion. Effect of the force on the motion. This is the basic concept regarding the mechanics and dynamics. बऱ्याच मुलांना मेकॅनिक्स आणि डायनामिक्स मध्ये फरकच लक्षात नाही येत. मग मेकॅनिक्स आणि डायनामिक्स म्हणजे काय असतो? Actually, what is the effect of a mechanics? What is the concept of a dynamics? You must know all these things. मेकॅनिक्स म्हणजे काय, डायनामिक्स म्हणजे काय, हे सर्व तुम्हाला माहित पाहिजे असतं. Mechanics, it is the branch of mathematics which deals with the nature of the forces and their action on a material body. Dynamics means what? Actually, dynamics means it is the branch of mathematics or mechanics which deals with the motion of the body or effect of the force. याच्यामध्ये फोर्स पाहतात, याच्यात इफेक्ट ऑफ फोर्स. आता इफेक्ट ऑफ फोर्स which can be divided into the two parts, which is called kinematics and kinetics. Now, kinematics means what? It is concerned purely with the geometrical aspect. Actually, फक्त आपल्याला geometrical aspect consideration करायचा असतो. आणि सेकंड मध्ये काय असतं पहा, and the second, for the second, in the kinetics, it is the effect of forces. It is the effect of forces. You must know all these things. Introduction पहा. See this. Actually, in this unit first, या ठिकाणी युनिट फर्स्ट मध्ये तुम्हाला कायनेमॅटिक्स अँड कायनेमॅटिक्स अँड डायनामिक्स हा पार्ट पाहिजे आहे, विच इज द पार्ट सेकंड पार्ट ऑफ द इफेक्ट, विच इज द सेकंड पार्ट ऑफ डायनामिक्स. So kinematics and dynamics of a particle of two bodies. In that introduction, you must know what is the concept. You must know in this introduction, you must know the concept regarding mechanics, dynamics, kinematics. Okay. तर या कन्सेप्ट तुम्हाला माहित पाहिजे असतात, लक्षात घ्या. नेक्स्ट, okay. Now we shall discuss the kinematics and dynamics of a particle in two dimension. Before starting the kinematics and dynamics of a particle in two dimension, you must know what is the concept of a particle. Because the study of a mechanics is basically depend on the particle. Study of a mechanics totally which is depend on the particles. So you must know what is the concept of a particle. चला रे स्टुडंट्स जे ऑनलाईन आहेत त्यांनी पार्टिकलची डेफिनेशन फास्ट सांगायचे का शॉर्ट मध्ये सांगायचे. व्हॉट इज द कन्सेप्ट ऑफ अ पार्टिकल. यू मस्ट नो व्हॉट इज द कन्सेप्ट ऑफ अ पार्टिकल. व्हाय इट इज नेसेसरी टू कन्सिडर अ पार्टिकल इन प्लेस ऑफ अ बॉडी. यू मस्ट नो ऑल दीज थिंग्स. या ठिकाणी या सर्व कन्सेप्ट, बिकॉज द स्टार्टिंग ऑफ द स्टडी ऑफ अ मेकॅनिक्स is from particle. हे तुम्हाला माहित पाहिजे. पार्टिकल पासून स्टडी सुरुवात होते. मीन्स व्हॉट इज द कन्सेप्ट ऑफ पार्टिकल. चला रे जे ऑनलाईन आहेत स्टुडंट, प्रत्येकाने आन्सर द्यायचं. चुकलं तरी चालेल, रॉंग झालं तरी चालेल, पण प्रत्येकाने आन्सर देणं खूप गरजेचं आहे. कारण जे आन्सर देतात त्यांचीच प्रेझेंटी इथं कन्सिडर होते, नाहीतर प्रेझेंटी कन्सिडर होत नाही. लक्षात घ्या. कारण काही मुलं फक्त प्रेझेंटी टाकून जातात. चुकू द्या, चुकलं तर चालेल, पण प्रत्येकाने इथं आन्सर देणं खूप गरजेचं आहे. ओके. नाउ पार्टिकल. पार्टिकल मीन्स व्हॉट. सपोज दिस इज अ रिजिड बॉडी. Suppose this is a rigid body. See here. Suppose this is a rigid body. If this body is under motion, if this body is moving, this body is in the motion. There are two types of a motion. First is a translation motion. Second is a rotational motion. Suppose this body is under the motion, then due to the motion of the body, suppose it is in the rotational motion, then every particle having a different directions. हे पास मोशन होत असताना याची या डायरेक्शन मध्ये असे या डायरेक्शन मध्ये दिस इज डिफरंट डायरेक्शन. अशा पद्धतीने तुम्हाला याची डिफरंट डायरेक्शन मिळू शकते. व्हेन अ बॉडी मूव्स, see this is a very important. Particle is a concept in the mechanics, is very important. When a body is moves, all the parts of the body have not necessarily the same motion, but if the body is very small, the differences between the motion of each part, motion of the different part is negligible. बॉडी जर खूप स्मॉल असेल तर प्रत्येक पार्टचा मोशन हा जवळपास इक्वल असतो. बॉडी जर लार्ज असेल तर तिचा मोशन हा वेगवेगळ्या ठिकाणी वेगवेगळ्या पद्धतीचा असतो. सो इफ वी कन्सिडर द स्मॉल बॉडी, रिजिड बॉडी इज ॲज अ पार्टिकल, then it has negligible differences between the motion of different part is negligible. So we regard the body as a coinciding geometrical point where the mass is concentrated, then it is called as a particle. Particle means, what is the particles here? A body having the body having a coinciding with the geometrical body, coinciding with a geometrical point where the mass is concentrated, then it is called a particle. Now here particles are denoted by a point because body is considered as a point, smallest part of a body. Suppose the smallest part of a body is considered as a particle. It is denoted by the letters as, suppose this is a particle P, this is a particle Q, okay, of the rigid body. See this, if we consider, suppose this is a rigid body, then we consider the smallest part of that rigid body is suppose a particle. So this is a particle P, this is a particle Q, this is a particle R. So we consider the smallest part of a rigid body. जेव्हा तुम्ही रिजिड बॉडीचा स्मॉलेस्ट पार्ट घेतात तेव्हा येणारे जे डिफरन्सेस आहेत, डिफरन्सेस बिटवीन द मोशन ऑफ डिफरंट पार्ट्स, difference between the motion of different part is negligible. So we have to consider the motion of a particle. Now hereafter we have to discuss the motion of a particle. मग आपल्याला इथून या चॅप्टर मध्ये आपल्याला काय डिस्कस करायचे? We have to discuss the motion of a particle. Rigid body नाही, the motion of a particle. Second definition, there is another second definition. Motion means we have to use the velocity. We have to discuss the velocity. सांगा रे definition काय? नेहा जाधव, साक्षी कदम, श्वेता शिंदे, शुभदा, ममता सापसोड, प्रतीक्षा, प्रणवती, Janvi Dage. Now you tell me the definition of velocity. Now here, suppose the rigid body, suppose this is a rigid body is displaces from one point to another point. if the rigid body moves from this point to this point, then this is called the displacement of that rigid body or displacement of a particle. Suppose initially the pen is at a point P, if we displace this pen at a point Q, then its position changes from point P to Q, and this is scientifically called as the displacement of a particle. Means when particle goes from one point to the another point, then it is said to be displaced, or it is said to be in motion. Motion म्हणजे असणे म्हणजे काय, which is displaced from one point to the another point. Here when a particle goes from one point to another point, then it is said to be displaced. It is said to be displaced or in motion. This is the definition of the displacement or motion. See this. When particle displaces from one point to the another point, then we can say that it is in the displacement, or it is the displaced, or it is in the motion. We can say that it is in the motion. But if we consider the motion in time, आता पहा, suppose a particle is displaced from point A to B, then it is a displacement. Particle displaces from A to B in how many times? How many time required to displace from A to B? This displacement is considered as under the time, then it is called as a velocity. So in the mathematics form, velocity, how to define the velocity? The rate of change of displacement, rate of change म्हणजे एका पॉइंट पासून दुसऱ्या पॉइंटला जाण्यासाठी किंवा पार्टिकलची मोशन मध्ये असताना एका पॉइंट पासून दुसऱ्या पॉइंटला डिस्प्लेस झाल्यानंतर त्याचा जो रेट आहे, रेट डिस्प्लेसमेंटचा रेट फास्ट आहे का स्लो आहे, that is called velocity. So we can define the velocity here, the rate of, बरोबर आहे, the Rutuja Kautikvar Bhosle, very good, the rate of change of shear, the rate of change of change किंवा rate of displacement, rate of change of displacement is called the velocity of a particle at that instant, velocity of a particle at that instant, and velocity is denoted by v bar is equals to, आता velocity स्टूडेंट सांगा रे, velocity ही स्केलर क्वांटिटी आहे का वेक्टर क्वांटिटी आहे? नाउ यू टेल मी, velocity is either scalar quantity or vector quantity. Means velocity means v is equals to ds by dt. Velocity magnitude ds by dt. v म्हणजे velocity, s means displacement. So velocity is equals to ds by dt. आता हे रिलेशन पाहणार आहोत. मग बरोबर आहे श्रद्धा जाधव. Velocity is a vector quantity. Note that here displacement is, velocity is a vector quantity. And displacement is, very good, Joshi, Sweta Sinde, Akshada Kadam. And displacement is a scalar quantity. Displacement is a scalar quantity. Now our aim is to prove the relation in terms of a vector, relation for the vector in terms of displacement or in terms of a velocity. Velocity आपण वेक्टर क्वांटिटी मध्ये एक्सप्रेस करणार आहोत. त्याच्या अगोदर ॲक्सेलरेशन सुद्धा माहित पाहिजे. म्हणून ॲक्सेलरेशन वी शॅल डिस्कस द नेक्स्ट स्टेप, ॲक्सेलरेशन. चलो रे स्टुडंट्स, हाउ टू डिफाइन द ॲक्सेलरेशन. How to define the acceleration? The rate of change of velocity. बरोबर आहे का रे स्टुडंट्स? चला डेफिनेशन सांगा ॲक्सेलरेशनची किंवा शॉर्टकट फॉर्म्युला सांगा. The rate of change of velocity is called acceleration. Is called acceleration. Okay, it is also vector quantity. Rate of a change of a velocity, it is called as acceleration. म्हणजेच acceleration a is equals to dv by dt, or which is called d2s by dt square. Now note that acceleration is a vector quantity. Here note, acceleration is a vector quantity. See this, if velocity is uniform, what is mean by uniform, students? If velocity is uniform, then at that time acceleration is 0. If the velocity is uniform, then acceleration is 0. Uniform means what? हाँ चला रे स्टूडेंट सांगा, what is mean by uniform? Velocity is uniform. Uniform means constant. Velocity अगर constant होती है तो acceleration constant का derivative, velocity अगर constant होती है, that means v is equals to, that is v is equals to constant, means uniform. Therefore a is equals to dv by dt. आणि कॉन्स्टंटचा डेरिव्हेटिव्ह कधीही कसा असतो स्टुडंट्स? 0 असतो. यू मस्ट नो दिस कन्सेप्ट. कॉन्स्टंट, व्हेरी गुड. साक्षी कदम, ज्योती पिटले, नीरज, एवढ्यांचंच लक्ष आहे. सय्यद तबस्सुम, असरिया गोरटे. ओके, इसका मतलब क्या है? वेलोसिटी इज यूनिफॉर्म, इसका मतलब वेलोसिटी इज अ कांस्टेंट. अगर वेलोसिटी कांस्टेंट होते हैं तो एक्सेलरेशन इज द रेट ऑफ चेंज ऑफ वेलोसिटी, मीन्स द डेरिवेटिव विथ रिस्पेक्ट टू टाइम. अगर कांस्टेंट है तो कांस्टेंट का डेरिवेटिव 0 होता है. सो डी एक्सेलरेशन ए इज इक्वल्स टू डीवी बाय dt. नाउ acceleration is a vector quantity, velocity is a vector quantity. So our next aim is to find the expression for the velocity and acceleration in terms of vector derivative, in terms of vector derivative. See this. So, now we shall discuss the theorem or theory problem to find the expression for velocity and acceleration in terms of vector derivative, in terms of vector derivative. See this is a important. Find the, this question is frequently asked in the examination, to find the expression for the velocity and acceleration in terms of a vector derivative. That means we have to find, actually you know that velocity is a vector quantity, acceleration is a vector quantity, so we have to find out the acceleration and velocity in terms of a vector derivative. See this, okay. So we can write this proof for solution. See this, consider a rigid body is moving along the plane curve C. Suppose, consider a rigid body is moving along the plane curve C. Suppose this is the rigid motion of the rigid body along the plane curve, along the plane curve C. At any instant of a time t, the position of a particle, suppose particle is moving along the plane curve. आता हा particle आहे C या plane curve मध्ये move होतो. At any instant of a time t, the position of a particle is at a point P. At a point P. Suppose this is the position of a particle at a point P when at any instant of a time t, then its position vector with respect to origin. Suppose position vector of a point P with respect to origin is considered as suppose r bar. After some small interval of a time delta t, this particle moves from point P to Q, from point P to Q. Suppose we consider this point is Q. ओके, थोडं डायग्राम व्यवस्थित काढतो मी, थांबा थोडं, म्हणजे तुम्हाला लक्षात येण्यासाठी. हा P to Q, this is a plane curve C. Then the position vector of a point Q with respect to T, with respect to O is r bar plus delta r bar. So OQ bar is equals to r bar plus delta r bar, OP bar is equals to P bar. So we consider this segment, suppose this direct segment, this segment is delta r bar. By using a triangle law, we can say PQ bar is equals to delta r bar. So this consider as a ratio, हा जो रेशो है डेल्टा आर बार अपॉन डेल्टा टी. So and this is a curve, PQ is a curve and tangent at a point P. आता हा आपण tangent at a point P काढला and that is a dr bar. We shall discuss, this is a dr bar by dt. We have to prove this dr bar by dt. See this, again I shall explain the concept regarding, consider a particle is moving along the plane curve C. At any instant of a time t, the position of a particle is at a point P. After some time delta t, the position of a particle is at a point Q. Let r bar be the position vector of a point P with respect to O. R bar plus delta r bar be the position of a position vector of a point q with respect to O. So we can write PQ bar is equals to delta R bar. This is the initial condition. Let, now see this, let the particle, a particle is moving along a curve C, curve C is in plane, and its position at any instant of a time t, at any instant of a time t be capital P. Full stop there. The position of a particle in time t plus delta t is at a point q. हे दोन कन्सेप्ट लक्षात ठेवा. Consider a particle is moving along the plane curve C. At any instant of a time t, the position of a particle is at a point P. In time t plus delta t, the position of a particle is at a point Q. Okay. Now see this. Let R bar and R bar plus delta R bar be the position vectors of the points P and Q respectively. Therefore, the vector PQ bar is equals to delta R bar. Therefore, we can write here OP bar is equals to R bar, OQ bar is equals to R bar plus delta R bar, and PQ bar is equals to delta R bar. According to the triangle law, we can take this. According to the triangle law, we can take this. Now see here, change of a position vector of the particle in time delta t, change of a position vector of a particle in time delta t, which is equals to delta R. The change of position of a particle in time delta t is given by delta t, small interval of time मध्ये particle कुठून कुठपर्यंत जातो, P पासून Q पर्यंत. Particle traveling through the point P to Q, so it is given by PQ bar, which is equals to delta R bar. But we know that by the definition of the velocity, it is the rate of change of position of particle. We know that velocity is the rate of change of a position of a particle velocity is the rate of change of position of a particle. Therefore, rate of change कुठून कुठपर्यंत झाला, delta R. Delta R means, see this, particle displaces from point P to Q. हा P पासून Q पर्यंत झालेला आहे in time delta t. Therefore, the ratio delta R bar upon delta t gives the average gives the average rate of change of displacement, average rate of change of displacement in time delta t. Okay, in time delta t. See this. So now see this. Now if delta t tends to 0, अगर क्या होता है, अगर डेल्टा t tends to 0, then the point q tends to p. Delta t, time in a delta t, particle displaces from point p to q. मग डेल्टा t अगर 0 होता है तो पार्टिकल q की पोजीशन p के पास आती है. So now limit delta t tends to 0, delta r bar upon delta t exist as t varies continuously. As t varies continuously means t is in continuously changing, t varies continuously. This means that delta t approaches to 0. This therefore, as delta t tends to 0, then the point q, then the point q approaches to point p. q हा point p जवळ अप्रोच होतो. Therefore this chord PQ, जी PQ chord आहे त्या PQ, Q अगर पॉइंट अप्रोच होता है P के पास, Q अगर P के पास अप्रोच होता है तो chord PQ becomes tangent at P. So therefore the chord PQ becomes tangent at a point P, at a point P to the curve C, and it is described by the particle, described by the particle. Okay, hence therefore it is the velocity, hence therefore limit delta t tends to 0, delta r bar upon delta t, which is denoted by dr bar by dt, which is denoted by dr bar by dt, which is the time derivative of r bar. Here this is the time derivative of r bar, giving the velocity of, which gives the velocity of a particle at P, which gives the velocity of a particle at P. Hence we get the relation, hence V bar is equals to dr bar by dt. This is the relation, this is the relation is called the velocity. So hence V bar is equals to dr bar by dt. This is the vector velocity, this is the vector velocity. This limit delta t tends to 0, delta r bar upon delta t exists, which is denoted by dr by dt, and which is the time rate derivative of r bar. R bar means the displacement of a particle from P to Q. So, it gives the velocity. Now, the magnitude of a velocity, सांगा रे स्टुडंट्स, चला पाहू द्या मला ऑनलाइन कोण कोण आहेत. Magnitude of a velocity is known as the speed of the particle. The magnitude of a velocity, this is the expression for the velocity in terms of vector derivative, in terms of vector derivatives. Now, the magnitude of a velocity, see here, the magnitude of a velocity V bar is called the speed of the particle, and which is the scalar quantity, speed of the particle which is scalar. So, therefore, magnitude of V bar is equals to magnitude of dr bar by dt, and which is equals to speed. Now, we have to find out the acceleration. Now, we have to find acceleration. Actually, now we have to find out the acceleration. Suppose that V bar and V bar plus delta V bar be the velocities of a particle at points P and Q respectively. पाहत आपल्याला काय काढायचं, acceleration. You know that acceleration means the rate of a change of velocity. So, suppose that at a point P the velocity of a particle is V bar. Also, we have to suppose that at a point Q the velocity of a particle is considered as V bar. Therefore, the change in velocity from point P to Q, see this, therefore, the change in velocity from point P to Q, we know that, therefore, velocity. The acceleration is related V bar just. Here dV bar by dt, here delta V bar by delta t will be the average, time rate of change of velocity, which will be the average acceleration, that will be the average acceleration. See this, here delta V bar upon delta t will be the average, average time rate of a change of velocity, that will be the average acceleration of the particle acceleration of a particle in interval of time delta t. Okay. Thus, the instant acceleration at a point P, therefore, the instant acceleration at a point P is given by A bar is equals to limit delta t tends to 0 delta V bar upon delta t if exist, and it is denoted by, therefore, A bar is equals to, what is that, dV bar by dt. See this. This is the expression for the acceleration in terms of vector derivative, or we can write this also, that is A bar is equals to d by dt of dr bar by dt. dr bar by dt velocity म्हणजे काय असतं, suppose this is equation number 1, V bar means dr bar by dt, so we can write velocity means dr bar by dt. So we get A bar is equals to d2 r bar by dt square. This is the acceleration in terms of a vector derivative. So this is the acceleration in terms of vector derivative. In terms of vector derivative series. अशा पद्धतीने हा थेरम प्रूव्ह होतो. लक्षात ठेवा, हा खूप महत्त्वाचा थेरम आहे. हा थेरम तुम्हाला समजलाच पाहिजे. परत एकदा मी थोडक्यात कमी वेळेमध्ये रिवाइज करतो. कन्सिडर अ पार्टिकल इज मूव्हिंग फ्रॉम अ पॉइंट along a plane curve C at any instant of a time t. The position of a particle is at a point P in time delta t, t plus delta t. The position of a particle is at a point Q. Therefore, in time delta t, particle moves from point P to Q. Let small r bar and r bar plus delta r bar be the position of a particle with respect to origin O. So, according to the triangle law, we can write PQ bar is equals to delta r bar. Now, if here delta r bar upon delta t, delta r bar upon delta t, which gives, see here, the average, which gives the average rate of change of displacement in time delta t. Now, limit delta t tends to 0, delta r bar by delta t there exist. As t varies continuously, then what will happen? As delta t tends to 0, the point Q approaches to the point P. That means the chord PQ becomes tangent at a point P to the curve C. Describes the particle. Hence, limit delta t tends to 0, delta r bar by delta t, if this limit exists, which gives a dr bar by dt. Thus, this is the time derivative of r bar, which gives the velocity. R bar means the displacement, velocity of a particle at t of a p. So it is denoted by V bar is equals to dr bar by dt. This is the expression for the velocity in terms of a vector derivative. The magnitude of a velocity V bar is called the speed. Velocity is a magnitude speed of the particle, which is a scalar and which gives magnitude of V bar is equals to dr bar by dt, which is speed. Now our aim is to find the acceleration of the particle. Suppose that V bar and V bar plus delta V bar is the velocity of a particle at a point P and Q. Therefore, delta V bar upon delta t will be the average time rate of change of velocity, that will be the average acceleration of a particle in interval of a time delta t. The instant acceleration at a point P is given by a bar is equals to limit delta t tends to 0 delta v bar upon delta t. If this limit exists, then it is denoted by dv bar by dt. According to the, हे कशावरनं घेतलं, लेबनिज थेरम वरनं घेतलं जातं. लेबनिज थेरम, what is that limit? Leibniz theorem, limit delta t tends to 0 delta y by delta x. If this limit exists, then it is denoted by dy by dt. So dv bar by dt acceleration. But we know that v bar means dr bar by dt. Replace this. So a bar is equals to d by dt of dr bar by dt means d2r bar by dt square. This is the acceleration in terms of a vector derivative. Okay. Thus we obtained two relation. Velocity means v bar is equals to dr bar by dt. This is the vector velocity in terms of a vector derivative. Also acceleration means a bar is equals to dv bar by dt or d2r bar by dt square. It is the second order time derivative of displacement. Okay. So these are the two relations for velocity and acceleration. Okay. आता याच्या नंतरचा पार्ट आपण उद्याला पाहू. या ठिकाणी थांबू. नमस्कार, गुड बाय. हे सर्व असाइनमेंट्स वेळेवर पाठवून देत चला. सर्व डीप मध्ये